Hello guys, in this video I'm gonna solve one of the solved examples basically in our book in the exercises. It's exercise 1 to 6. Okay, chapter 1, section 2, problem 6. And this example is also solved, but the solution is very confusing for me as well. It was confusing even for me. Okay, so I'm gonna solve it. Okay, then I'm gonna go back to the solution and see why it's confusing. Okay, so here is the problem. Express the last equation of each system. So we have here two systems, problems. One is the same problem, problem A and problem B, as multiple of the first two equations. So if we called, for example, this is equation 3, equation 2, equation 1. So basically what he's saying is that express the last equation, equation 3, as multiples of the first two equations, like it's equal to a constant. Let's call it A multiplied by equation 1 plus another constant or multiple, basically B. Let's call it B multiplied by E2 for equation 2. That's basically what you want. But he don't want A and B. He want what is A and what is B. That's basically what's required by this question. And he want you to do it in using Gaussian elimination. Okay, that's what we're gonna do right now. So, and here is basically the solution. What a little bit confusing. So I'm gonna leave it to the end. Okay, so let's do it first and see the given solution. Compare it. Okay, so here is basically the system again, and here is what you want. Basically, let's write it other way. You want A3 equal to A, B1 plus B equation 2 by B2. And we should find A and B. Okay. So what we should do, we should multiply equation by 1 by A, equation 2 by B. And the addition of these two equations should should equal to equation 3. So let's write this down. So we're gonna multiply equation 1 by A. So A is 1, 2A x2 minus 3A x3 equal to minus 3A. Okay, equation 2 should be multiplied by B. X1 plus 3bx2 minus 5bx equal to 5b. And equation 3 should be the same. x1 minus 2x2 plus 5x3 equal to minus 35. What is that? This is A, equation 1. What is that? This is B, equation 2. What is that? This is just equation 3. Now the trick is to find some variables, unknowns, A and B. In that case, we should have at least two equations, to solve them together using Gaussian elimination and get A and B. Okay, so we should construct from that system here that we see that it has three equations. We should construct a system for A and B, not for x1 and x2 and x3. We should do that now. So let's look and have a careful look at this equation to construct these new equations out of this system. Okay, we are saying that E3 should be equal to AE1 plus BE2. Okay, so the corresponding terms in each equation, should be equivalent to each other. What does that mean? So what I should say here is that when we add this term plus that term should give us that term. So the first equation is that A plus B should be equal to 1. That's the first equation in A and B. We should also say that when we add 2ax2 plus 3bx2, that should be equal to minus 2x2. That's the second equation. 3a plus, or I'm sorry, 2a, not 3. 2a plus 3b should be equal to minus 2. That's the equation 2. Somebody will say, oh, we should say ax1 plus bx1 equal to x1. Yeah, that's fine, my friend. Just divide by x1. It will be equal to a plus b equal to 1. That's basically equation 1. That's why we just look at the constant in front of the variable. Okay. Now again, when we add, according to that equation here, E3, E1 plus PE2, when we add the term that contains X3 plus that term here, that should give us that one. So minus 3A minus 5B, that should be equal to plus minus 5. That's equation 3. So we have other equations. Yes, we have other. This one, even the constant term on the right hand side. Okay, so minus 3a plus 5b equal to minus 35. We have 4 equations in only 2 unknowns. Okay, that's gonna reduce to 2 equations, basically because we have 2 dependent equations. Okay, just take this from me right now. If you have a background, you will understand what I'm saying. In the future, this is gonna be more clear for us. What is independent or what's dependent equations means. We're gonna see this in later chapters. But as a hint now, when you have dependent equations, okay, you're gonna see zeros. You're gonna see a whole row in the matrix equal to 0 using Gaussian elimination. Okay, that's what we're gonna see now. We're gonna see 2 rows, 2 complete rows, zeros. That means these 2 rows, these 2 equations was dependent on another 2 equations. That's why they just vanished to the Gaussian elimination. Okay. So let's do that. So now we have a system. This is a system of linear equations. Okay, so we can do Gaussian elimination. To get A and B. Like what we did before to get X on Y and Z, or X on Y, or X1, X2, X3, and so on, right? So let's write that down as a matrix. 1, 1, and 1 here, 1 here, and 2, 3, minus 2, minus 3, minus 5, and 5. That's the last equation. Write A, 5, and minus 35. Okay, and we just apply Gaussian elimination. Very easy. Okay, luckily we have our first row as well. Otherwise, search for this one and just change the rows, swap the rows. That's fine. So what we're gonna do to make this 0, multiply the first equation by 2 and subtract 2 equation on I'm sorry, from equation 2. So basically, this equation here will be 2e1. I'm sorry, it's gonna be so row 2, new, the new row, the new second row will be the old row R2 old, which is that one here. That's the old row. This is the old R2 old. minus 2 or 1. So we're gonna multiply row 1 by 2, then we apply this. Okay. So when we multiply here, let's see, with like rate, for example, this would be 2, this will be 2. Then we subtract 2 minus 2 is 0. 3 minus 2 is 1. Minus 2 minus 2 minus 4. Good. Okay. Let's now just remove that. So small. Okay. Now we want also to make this minus 3 as 0. Okay. So we should multiply row 1 by 3 and just add. So R3 new equal to R3 old plus 3R1. Okay. This is basically the row here. R3 old. It's going to be replaced by a new R3. So let's do this by green, for example. So we're going to multiply. So this will be minus 3, minus 3, minus 3. I'm sorry, we're going to multiply by 3, not minus. Yeah, 3, 3. Okay, minus 3 plus 3, this is minus 5 plus 3, minus 2. 5 plus 3, this is 8. Good. Finally, we're gonna also get rid of this like guy here. So we're gonna just again multiply by 3. So R4 3 or 1 again. R. Okay, so minus 3 plus 3, this is 0. 5 plus 3, 8. Minus 35 plus 3, this is minus 32. Good. Now, good. So success, we just make this like pivot here 1, only the one in this column. Now we should look at the second put this guy here. So we should guys to see. Okay. So how we do that? So let's see. Let's write this down again. 1, 1, 1, 2, 1 minus 4, minus 2, 8, 8 minus 32. Okay. Now we should look at this column here, this one. Okay. So what we should do? We should multiply this by 2. So let's do this. To reduce the minus 2 to 0, we should multiply. So R3 equal to R3 plus 2R2. So this is R2, of course. This is R2. We're going to multiply it by 2, then add to it R3. This is R3 old. The new R3 old. Because we have R3 old. Okay. Okay. So if we do this, we should multiply by 2 minus 8. Okay. So row 1 will not be affected anyway. So write it down. Row 2 also will not be affected. So minus 2 plus 2, this is 0. 8 minus 8, this will be also, or 8 plus minus 8. And that's what I said, guys. We have 4 equations and 2 unknowns. So we should like 2 equations will disappear. This is the first one that disappeared. Okay. Okay, let's now do this for R4. Let's remove 8 to 0. So we're gonna let's remove this in the -8. Right? Or make it green, that's fine. We should multiply this by 8 minus 32. Then we should subtract. So should say here that R4 new equal to R4 old plus 8 R2 R4 old. Okay. Of course, 8 times 0 is 0. So 0 minus 0 again is 0. 8 minus 8 is 0 minus 32 minus 32. It will be plus 32. So minus 32 plus 32, that's again 0. That's why they vanished. We have before the 4 equations and 2 unknowns only. So 2 will disappear automatically when you do Gaussian elimination. Good. Now we can write freely. So that's what we end up with. Equations. So we can just write this down. A plus B equal to 1 from the first equation, first row. We can also write from here 0A, which is 0, plus B equal to -4. So B equal to -4 automatically. Then we take this -4 and put it here. So from that A -4 equal to 1, from that A equal to 5. That's it, guys. We solve it. This example, okay? Simply. So we can say now, that R3 equal to, sorry, equation 3. You can also call it row in a matrix form, that's fine. So equation 3 equal to AR1, 5, or 5 equation 1, plus -4, it will be -4 equation 2. That's the solution. Can we check if our solution is correct or wrong? Yes, we can do that very easy. Very easy. So what you need to do, multiply 5 by equation 1, multiply -4 by equation 2, and add them together. You should get R3 or equation 3. So let's do that. Let's do that. We can look, yeah, so it's in here. Let's do that. Even we can do that here. So let's see. So A is 5 and B is -4. So let's do that. Okay, 5x1 plus 10x2 minus 15x3 equal to -50. Good. That's 5 multiplied by equation 1. Let's now multiply equation 2 by -4. -4x1 minus 12x2 minus 20. I'm sorry, plus, because -5 multiplied by -4, it will be plus -9. x3 equal to 5 multiplied by -4, it's -20. Let's add these together. What you're gonna need to do, is the corresponding terms, add them together. So x1 term will be added separately from x2 term, from x3 term, from the constant term. So let's start by the first x1 and -4x1. This is 1x1. 4x1. Good. 10x2 minus 12x2. This is -2x2. Minus 15x3 plus 20x3. 5x3. Minus 15 minus 20 minus 35. Let's compare now. x1, x1. Minus 2x2 minus 2x2. Plus 5x3 plus 5x3. minus 35, minus 35. So the solution is correct. A equal to 5, B equal to minus 4 is correct. Absolutely, 100%. Okay, so now let's go back to our like the solution manual and what he's doing here. So what he did here is basically he tried to make the shape of the new system, the system A and B, this system here, this system that we just created, this one, in a similar form to the original form. So this system here is basically this the size of this matrix, for example, is 4 by 3. We have 4 rows, 3 columns. Okay, the original system, this system, if we write it as a matrix, it will be 1, 2, 3, 4. It will be 4 columns. How many rows? 1, 2, 3. So it will be 3 by 4. So what he did is that he transposed this system. He transposed the system. Okay. Let's check on that. So the first row should be the first column. 1, 1, 1, 1. So let's see. Yes, 1, 1, 1. The second row should be the second column. 2, 3 minus 2. 2, 3 minus 2. Perfect. The third row should be the third column. Minus 3 minus 5, 5. Minus 3 minus 5. Yes. Minus 3 minus 5, 5. Let's check again. Minus 3 minus 5, 5. Yes. The fourth row should be the fourth column. Minus 3, 5, minus 35. Minus 3, 5, minus 35. Okay? That's basically what he did. Okay, guys, I don't know what is the purpose of doing that, but, you know, you have basically I think it's basically to make it like similar to the original system. Also, I don't care about that, but both will give you the correct answer. Don't worry about that. Okay. Okay, guys, that was it. Thank you very much for watching, and see you in another video. Bye-bye.